Okay, welcome to the first tutorial video that we've actually done. This is on calculating the empirical formula of a compound. Before I start, please can I ask you to make sure you have a calculator to hand, make sure you have a periodic table to hand, and make sure you have a piece of paper and a pen so you can jot things down as we go along. Before we do anything, we need to look at actually what an empirical formula actually is. Up to this point, you've all been using, quite happily, the term molecular formula. Okay, I'm a little bit confused on why my pen has suddenly started doing this. Ah yes, I'm back with it. So we've been using molecular formula. So if I use, for example, hydrogen peroxide, which is H2O2, the molecular formula of hydrogen peroxide is H2O2. You've got two atoms of hydrogen in the molecule, and these are bonded to two atoms of oxygen. Now the empirical formula tells you something slightly different. All the empirical formula tells you is the ratio of the different atoms within the molecule. So the ratio of atoms within hydrogen peroxide, clearly it's 2 to 2, so that's effectively the lowest ratio is 1 to 1. So the formula is just HO. Now benzene is a chemical you've never met before. Hydrogen peroxide you met when generating oxygen. But benzene you've not seen before, and that has the compound, the molecular formula C6H6. Again, if we're asked to find the empirical formula of that, we look at the ratio of atoms in there, and, well, like hydrogen peroxide, it's a 1 to 1. So this would have an empirical formula of C6, or sorry, it wouldn't, CH, 1 to 1. So, now we know what the empirical formula actually is, we can get on with the calculation. So the first calculation here is one containing 3 elements. This compound contains 60% carbon, 13.3% hydrogen, and 26.7% oxygen. Now this is a very common GCSE question, and the advice I would give you at the start is just to construct a table showing the different elements in our compounds, and at the top to write down the data you have been given. Now this data here is the percentages. It wouldn't matter if it was mass, if they were measured in grams. We could still do the same thing, writing the mass of each at the top of each column. The next thing you do is to get your periodic table out and to find the relative atomic mass of each element. Carbon, in group 4, has a relative atomic mass of 12. Hydrogen has a relative atomic mass of 1, and oxygen has a relative atomic mass of 16. They're all on your periodic table. So you do those divisions, and 60 divided by 12 gives 5, 13.3 divided by 1 gives 13.3, and 26.7 divided by 16 gives 1.67. Now, after that, you need to do another division. What you do is you find your smallest number here, and then you divide all of these by the smallest number. So you have 5 divided by 1.67, 13.3 divided by 1.67, and 1.67 divided by itself. Type those into a calculator. Unsurprisingly, 1.67 divided by 1.67 gives 1, 13.3 divided by 1.67 gives 7.96, and 5 divided by 1.67 gives 2.996. Now you can see that this number here is incredibly close to 3. It effectively can be rounded up to 3. This here is incredibly close to 8, and this number is in fact 1. So the ratio of the 3 elements to each other is 3 to 8 to 1. We need to finish off our question by writing out the final formula. So it's C3H8O. And you need to do that to finish with. Now, before we go on to a second example, I'd just like you to think about what we did at each step. What did we do here? And what did we do here? We did 2 divisions. With the first one, we divided it by these numbers here. Where did these numbers come from? Well, these were our relative atomic masses of each element. The second division well, where did this 1.67 come from? Well, actually, that was the answer up here. We divided it by the smallest answer that we got from our first division. And that gave us our ratios here. You are actually getting the ratio here, but this here the ratio is in a much more manageable format. That is how we would do an empirical formula calculation. There are a few twists, and the next question shows you one of those twists. Now, at first glance, this looks a little bit easier. You've only got two elements, oxygen and iron. But what they've only told you is how much iron is in there. Now, as it's a percentage, it's fairly easy to work out how much oxygen is actually in there, because clearly if the compound is 100% iron and oxygen, iron is 72%, the rest has to be oxygen. So quick subtraction there gives 28. Now think back to the last question. What did we do to get to our ratio? We did two divisions. What did we divide by at each point? The first time we divided by relative atomic mass, and the second time we divided by the smallest. I apologise for my handwriting, it's terrible. So, get your periodic table out again, find iron, find its relative atomic mass, the bigger of the two numbers next to iron, and iron has a relative atomic mass of 56. Oxygen has a relative atomic mass of 16, and that gives us, if we do those calculations on the calculator, 1.29, and this one here, 1.75. Now, these numbers again, we have to deal with by finding the smallest. Now the smallest is clearly 1.29. So 1.29 divided by 1.29, and what we do to the left, we do to the right. So we end up with 1.29 divided by 1.29, which gives 1. 1.75 divided by 1.29, that gives 1.36. Now here's the twist I was telling you about. Most pupils, okay, will get to this point and they'll see, yes, 1 to 1.36. Well, 1.36 is nearly 1. So that's a 1-to-1 ratio, and the empirical formula must be FeO. Well, in fact, I'm afraid that's not actually right. Okay, 1.36 is the 0.36 is too big a decimal to simply round down to 1. So what we need to do is to scale this ratio up to give us a whole value, give us whole values on each side. Now let's try and double each side. Maybe if we double it, we'll end up with whole numbers. Well, this gives 2, and this gives 2.72. Again, 2.72, or 0.72, is too big to be rounded down, and is obviously not quite big enough to be rounded up to 3. It's still a significant distance away from 3. So maybe instead of timesing it by 2, we could times it by 3. 1 times by 3 is obviously 3. 1.36 times by 3, okay, gives 4.07. Jackpot. Here we have a number which is close enough to the integer to be able to round it down. So we effectively have 3 to 4, and our empirical formula of this iron oxide is Fe3O4. And those of you sort of wanting to sort of push yourselves will look at your valency of iron. Okay, and you'll think, well, iron has a valency of either 2 plus or 3 plus. How can it have a formula of Fe3O4? And that's something I'd like you to think about, okay, and maybe come and ask one of us, or check the answer that you've come up with one of us. However, this tutorial is about empirical formulae, and that would be the answer to this question. Right, look at the steps we've done on each stage. Divided by the relative atomic mass, divide by the smallest, and then work your ratio up if needed. Last question. Here we've got a sulfide, which we've presumably made by heating copper with sulfur. So 2.67 grams of copper. And the rest of the compound must be sulfur. So 2.67. They've told you here that the total mass of the compound was 4.01. So the mass of sulfur that has reacted with the copper actually is 1.34. Notice here I'm using grams. Okay, we can use grams in exactly the same way as we use percentages. Again, think about what you did at each step. 2 divisions. The first one by relative atomic mass, and the second one by the smallest. Hopefully by this stage you're doing this automatically. So again, get your periodic table out. We need to divide by copper's relative atomic mass. Copper is 63.5. Sulfur, find that, it's in group 2, that's 32. And if you plug those numbers into your calculator, you come out with these. You may look at this and think, oh, these two numbers are very similar, it's going to be a 1-to-1 ratio. I'd urge you just to be a little bit careful before jumping to conclusions. So again, dividing it by the smallest, this one being the smallest. And yes, if you'd made that original conclusion, you were quite right. Okay, but it's best to check, particularly in an exam when you might be a little bit nervous. Let's finish off the question. So it's a 1-to-1 ratio. So our empirical formula, I was about to write Fe for that, but no, it's copper. Okay, it's CuS, and that's our final answer. Now what you should be doing is going away to practice some of these questions on your own. Use the tutorial to help you through each step, and then once you're competent at this, move on to calculating the formula of hydrated salts.